Hey class, so sorry that I won't be there again today to help you review for your test. So I just wanted to take some time and go through some of the problems on the review and some key things to highlight so that you're prepared for the test tomorrow. So first, this is exactly what the test review formula part will be on the formulas for the areas of the triangles. And then I just wanted to go through which formula you use in which situation, so that it's very clear. So there's the formula sheet, and then you have this same formulas. They're on your workbook, front cover of your workbook. So that's where I got this picture from. So if you know the base and the height, you can use the standard area of a triangle, 1/2 base and height. If you know two sides and an included angle, you're using the formula like this. And that's going to look like if you have, this, that this side is 4 and this side, and you have an angle and this side is 6. Then you can find the area using this formula. It doesn't really matter which sides are which. Like even if I said that this side was A, this side was B, and this side was C, technically this would be little a, little b, little c. They correspond across. But all that matters is that the angle is included in the two sides. And so you would set this up as the area would equal 1/2 times the two sides that are around that angle times the sine of that angle. And that would give you the area of the triangle. So you can use that anytime you have two sides and an included angle. If you know 3 of the sides, I guess I drew kind of a right triangle, but let's assume it's not a right triangle, and this was like 7, 9, 16, so this to be like 13. If you know 3 of the sides, then you can use this formula right here to find the area. And you don't need to try to solve for any of the angles. If I'm just looking for the area, just use this formula. You have to start by finding the small s, which is the semi-perimeter. So you would start by adding all the sides together and dividing them by 2. So we get 16 plus 13 be 29 divided by 2 be 14.5, and then you just plug it in. So the big S then is your area, and you would do 14.5 times 14.5 minus 7, then do 14.5 minus 9, then 14.5 minus 13, all under the square root, and that would give you the area. And then the last case is if you know 2 of the angles and a side. And this is the one where the most mistakes are made from the quiz. So if you know 2 of the angles and a side, like angle, side, angle, or angle, angle, side, you can use this formula. But the key is that these two, this angle and this side, have to match up. For example, if I take my side, so let's say I know angle, angle, and a side. So 35, 27, and then I have a side length of 9. And I'm just kind of making it up. And let's see if this was labeled ABC. Okay. The key is that this side goes across this angle. So if I was to give you this without the diagram, I would say angle A was 35 degrees, angle B was 27 degrees, and side A was 9. Because I gave you angle A and side A, that's what you would use for these pieces right here. You would have to solve for that third angle by subtracting these 2 that you're given from 180. So 180 take away 35 and take away 27 would leave you with 118. And then when you plug it into your formula, you're going to use the side that matches up with the angle as the top and bottom. So you're going to do like the 9 squared, then you would do sine of 27, sine of 118, your other two angles, and then 2 sine of 35. So the key is that the 9 was across from the 35, and those have to be put together then like the formula like that. They have to be across from each other. Those two angles must match up. So that's how to identify the different triangular formulas and use them. Those formulas will be given just like this. Now, law of cosines and law of sines will not, the formula will not be given to you. So you do need to know these. You really only need to learn one of the two and like one of these, and then when to use them. So law of sines is best used when you have angle, angle, side, angle, or you have side, 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 the ambiguous case. So if anytime you're given two angles and a side length, you can use law of sines because you can set up a proportion, two angles and a side, and then solve for the missing side. Or the ambiguous case, you're given two sides and an angle, solve for this missing angle. When you use law of cosines is side, side, side. So if you're given A, B, C, then you can solve for the angle A by using your inverse functions. Or if you're given side, angle, side. So if you're given side, angle, side, then you're doing side, side, angle, side, and then you're solving for the missing side length. This one, though, the angle has to be in the middle, so it would be like A, B, C, A, B, C. So in order to find, like, let's say we're finding this angle here, or the B, side B. If you're finding B, then you do B squared equal to, then you use the sides across, so C squared plus A squared. Then you subtract 2 times C times A, and then you use the cosine times the cosine of the angle directly across from it. So that's how those match up. The value, the side squared, always corresponds with the angle across from it in the law of cosines formula. Sorry. Okay. The last one I wanted to talk about before I do some examples is the ambiguous case and when to use it. You only have to check if it's ambiguous when you have side-side angle. Knowing only side-side angle doesn't work because the unknown side can be located in two different places. So here's a little diagram for you. Notice that if we have a triangle and you have your angle here, if you have side-side angle, notice the second triangle still has side-side angle, but the triangles are not congruent anymore. This angle up here is not the same, and this side is not the same. And so we have two separate answers. So when we are solving this triangle, we're finding our missing angles, these two angles, and our missing side length. And that's one answer. But because sometimes there's a possibility that angle could be a different angle and then two different angles and a different side length. That's why we have this ambiguous case. But notice that this original angle that we started with and these two sides stay the same. And then the new angles that we're solving for and that missing side length are different. So that's why we get two different answers with that. And so I think I'm going to start with an example for the ambiguous case. So I'm just going to go into your workbook. And I'm actually going to go back up to page 11, and I'm going to look for one where I would have multiple cases. Okay, sorry, changed my mind. I'm just going to stick to the ones on the review, but these ones are solve the triangle, be sure to check for multiple solutions. Okay. So when I first look here, when I solving the triangle, the ones that could have multiple solutions are anything that has side-side angle. And so number one could be side angle, and number 4 could be side angle because I have side and an angle given. So the only time you have to check to see if there are 2 possible answers is when you're given side angle. So first I'm going to draw this triangle out. Looks like angle A is 112 degrees, and then side A is 14, and side C is 16. I can tell right away that this is going to be no solution because my angle A is an obtuse angle, which means that the side across from that obtuse angle should be the largest side, but this side B is bigger than side A, which is 14, so this is going to have no solution. If you didn't see that right away, you could set up a law of sines. Sine of 112 over 14 is going to be equal to the sine of B over 16, and you would end up with the sine of B being equal to a value that's greater than 1, and it would end up giving you an error in your calculator, so you know that that's going to be no solution. The other possible multiple answers is number 4, because I'm given another side angle. So when I draw this out, and the picture isn't super necessary, but A is 43, side A is, and then side B is 8. Okay, so I'm going to start by solving this triangle. So I'm going to start by trying to find my missing angle measurements. So I'm going to do sine of 43 over 6. So using the law of sines, those two go together, is going to be equal to the sine of B over 8. So it's going to be the sine of B. I'm going to do 8 times 43, sine of 43, and then 6 times sine of B. So 6 sine of B equals 8 sine of 43. So we're going to have sine of B is going to be this divided by 6. So 8 sine of 43 divided by 6. And then I'm going to get that decimal, and I'm going to take the inverse sign of that decimal. And I'm going to get B is equal to 65.4 degrees. We're going to round to the nearest tenth. So we got 65.4 in this triangle. So then I can find angle C by taking 180 minus the 43 that's in there minus the 65.4. And I'm going to get 72.6. Whoops. Now you can use law of sines or law of cosines to find your missing side. And this one, my missing side is my side C. So angle C was 72.6 degrees. And then I need my side C as well. And so you could do law of cosines or law of sines. If you did law of cosines, you would say that C squared is equal to 8 squared plus 6 squared minus 2. 8 times 6, and then use the cosine of the angle across from it. And then plug that in, take the square root. Or you could do law of sines. So you would say like the sine of 43 over 6 is equal to the sine of 72.6 over C. I think law of sines would be easier in this case. So you would take 6 times the sine of 72.6 and then divide it by the sine of 43 after you cross multiply. So you get 8.4. And that's the first triangle. But this has a possibility for multiple answers because I was given side angle. So only because it's side angle do I need to check for another answer. And so I'm going to go back to the original triangle that I had here. And I had A was 43 degrees, and then I had 6 and 8. And I found my first angle to be 65.4 degrees for B. But 65.4 degrees was my sine value, and sine can also be, sine's also positive in the first quadrant. So I'm going to find that reference angle, or that angle in the second quadrant. So I'm going to take 180 minus the 65.4. I'm going to get 114.6. So my other answer for B could be 114.6. And then I want to check to see if that works. So 43 plus 114.6 gives me 157. And if I take 157, take away from 180, that leaves me with a possible answer of 22.4 degrees for angle C. So this is a possible answer for the triangle. So I could have another triangle here where my B value would be 114.6 degrees, my C value would be 22.4 degrees, and now I have to resolve for my sine of C. I could set it up the same way with the law of cosines up here, but I would change the angle in here to 22.4, or I could do the same thing here, do law of sines and do 22.4 with my law of sines. So that would be 6 times the sine of 22.4, and then divided that by the sine of 43. So cross multiplying, which would be 3.4. And that would be my other triangle answer. And when you are solving these, try to organize your answers based off of the triangle so that we can tell which one goes with which. So I can tell that these answers went with this triangle and these answers went with this triangle. Otherwise, it's just it's a little confusing to know which C value goes with which angle, etc. So try to keep that a little bit organized. Now I know that I won't have to check for multiple answers here because I'm giving angle, side. And so when you are looking to find the information for here, since you're given two angles, you know that the only possibility for your third angle is that 61 degrees. And then you're given side A is 15. So you could use a combination of law of sines to figure out the other sides. So solving a triangle means to find all of the missing sides and angles. This one I'm giving you, if you draw it out, ABC, I'm giving you 38 and then 46, and I'm giving you angle 53. So I'm giving you side, angle, side. So even though I listed two sides and an angle, I'm giving them to you in side, angle, side, so you do not have to check for a third case. Since you're given the included angle, I would start by solving for B using the law of cosines. So you get B squared is equal to, and then you would do the two sides surrounding that angle squared minus 2 times those sides times, and then the cosine of that included angle. And then you would take the square root of what you got there. And then I guess you could then do law of sines to find one of these angles too, once you have those other two sides. Or you could do law of cosines to find the angle once you have that side, but you have to start with that side. Okay. So the area formulas. So if you're given three sides, find the semi-perimeter, and then use that one with the square root. If you're giving a side angle and a side, then use that first formula, or the formula that goes like this, where it's like 1/2 AB sine of C. So if we draw this out, B is 35, A is 27, and then side C was 32. And you can see that the 32 is included in the 27. And so you would use 32 would be this angle, and you would do 1/2 of 27 times 35 times the sine of 32. Okay, so here you're given angle, and a side. And so you can find the third angle by subtracting the first two from 180. So So 180 minus 72 minus 85 is 23 degrees. Then notice that you're given angle A and side A. So when you're plugging into the formula for area, you're going to use the formula that has the squared and then the two signs. And you're going to match these A's up. So you're going to have 46 squared, and that's going to go with 2 times the sine of 72. So those have to go together because they go across from each other. They're both A's. The other angles, it doesn't matter which order they go in. So you could do sine of 85 times sine of 23 or vice versa. Sine of 23 times sine of 85. But it does matter that these are both A's, so one goes as squared and the other one goes on the bottom there. So those have to match up. Okay, I'll help you get started on these ones. I'm not going to do all of them though. I'm sure you're done listening at this point anyway. I've made it a little bit longer than I wanted. The diagonals of a parallelogram are 56 and 34 inches and intersect at an angle of 62 degrees. So I got a parallelogram here, and I got two diagonals, and they're intersecting at 62 degrees. So that's going to be the non-obtuse angle. And then they are 64 and 34 inches, which means that my longer diagonals are going to be 28 inches each. And then my short diagonals will be 17 inches each. And then to find the length of the longer side, so first I would find this missing angle by adding it or subtracting 62 from 180 and getting 118. And then I can use the law of cosines because you have two sides and an included angle. So you could do the law of cosines. So Ashley looks up on the top of King Kong's head. So, I don't know. Here's his head. Finds that her angle of elevation is 68 degrees. She walks 445 feet further. And then her angle of elevation is now 18 degrees. How tall is King Kong? So we're looking for this value right here. The first thing I would do is, after setting up a diagram like this, would be label. I know this was 145 feet, and then 112 plus 68 would be 180, so I can complete that, get that angle there. And then I can finish off this triangle, and I know that this is 50 feet. Since both of these triangles share this side length right here, I would start by finding that value by doing law of sines and finding y. Once you have the y value that you found using the smaller triangle here in law of sines, then you can use just basic trig here, because you have a right triangle and you have an angle here and you have the opposite and the hypotenuse, so you could use the sine value. So set it up, find the side that they share using law of sines or law of cosines. Actually, you have to use law of sines because you don't have two side lengths. So law of sines, and then use sine of 68 opposite over hypotenuse to solve for the height. Okay, hopefully that was helpful. Sorry I couldn't be there.